Okay, so we've looked at multiplying indices, dividing indices, zero indices, negative indices. Today, last thing, what happens when you have a fraction as one of these powers? Okay, so how are we going to consider this? Let's think of an example. Let's think of something like, say, 3, and let's put a fraction in the power. We'll start with an easy one. Let's put a half. Okay. Now my question is, what is this thing equal to? Okay. Now,
So if I just write 3, oh, you can't do like.
Okay. Now, see, here's the problem, right? The whole idea of indices, right, is like not a law, but it's like a to the power of m means you multiply the number by itself, and you do it m times, right? But I don't have a number of times. Like, what does it mean to multiply a number by itself half a time? Like, that doesn't really make sense. Okay, so here's the way I'm going to approach it. I'm going to think about these laws and see if I can do something that'll make sense here. Suppose, which way shall I take it? Let's go this one. Yeah, this one here. Okay, first one, the very first one, the simplest one. If I were to multiply this number by another number, same base, for the purpose of illustration, I'm going to make the power the same as well. Okay, 3 to the power of a half times 3 to the power of a half. According to this first law that we established ages ago, what should I do to the indices? I should add them. Like so. Well, what's a half plus a half? It's just 1, right? Hold on. 3 to the power of 1 is just 3. Like that. Okay. Now hold on a second. What does this mean? We're trying to work out what is 3 to the power of a half. What is that thing? Okay. Now, what we've noticed is that this, if you multiply it by itself, you get 3. What number do you multiply by itself to give you 3? Now, we need some new notation here. You actually all know this number. We call it the square root of 3, right? If you multiply the square root of 3 by the square root of 3, you get 3, okay? In fact, that's what square root means. It's the number that you multiply it by itself, and it will give you back this guy, okay? All right, let's push forward. Let's have a look at some other fractions. Let's try, for instance, so this was example 1. Let's do example 2. Let's go with a number like, say, 5, okay? Let's take a different fraction up there, okay? Let's do a third. A third? A third, okay? Now, I want to try and do a similar kind of trick, pull something out of the hat like this, so I can work out what 5 to the power of a third, whatever that is, what's it equal to, okay? So I'm going to multiply by something. Any suggestions? What should I multiply by?
7.
I can multiply by 7, but would you get much meaningful out of that?
You just multiply by the same.
I might multiply it by itself. Okay? Now, for reasons that will become clear in a second, I'm going to multiply it by itself one more time. 3 times rather than 2. I wonder if you can see where I'm going, okay?
The denominator is
Okay, alright, hold on. Be careful about your numbers, right? It is about the denominator. Multiplying numbers all with the same base, so what I do with the indices?
Add them.
I'm going to add them. Okay. So I've got a third, plus a third, plus a third again. That's 1, isn't it? Third plus a third plus a third. So 5 to the power of 1 is 5. Okay. So I've got some number. And when I multiply it by itself 3 times, I end up with 5. Okay? Well, here we call this the square root, right? If you square the square root of 3, you'll get 3. Okay? But we call this a different number. It's not square root, is it? Right?
Cube root.
It's called the cube root. Okay? We write it like this in a very similar way. We write it with a 3 outside there. I read that as the cube root of 5. Okay? Cube root of 5. In fact, I might even write that for you. Yep.
Why to the times rather than plus?
Yeah.
Where?
On the cube plus the cube.
Here.
Yeah.
Because it's this. There's multiplication there.
Like, no.
If I added these together, I wouldn't get 5. I have to multiply them together to get 5. Okay. Yep.
Is the 3 there because there's 3 5s?
Do you mean this 3
Yeah.
or this 3?
Like, no, you have 3 where the square root is.
There, yeah, okay. So that 3 there indicates it's not the square root, that's what it
Yeah.
usually means, it's the cube root. And I can actually keep going. I could not just have the square root or the cube root. I have different other kinds of, well, not 2s or 3s, but let's do some other crazy number, okay? Let's do 10. Okay, let's do 10. Here's my third example, okay? This time I'm going to go to, let's try this law instead because I don't want to write this out 10 times, okay? Let's go 7 to the power of 1/10, okay? Now if I multiply this number by itself 10 times, see that? That's multiply whatever's in there by itself 10 times, okay? According to this law in here, 1, 2, 3, 4, okay? This is power of a power. So what do I do to the indices? I multiply them, right? You see what's going on? So that's a 10th times 10. That's just 7 to the power of 1, which is 7. Okay? So what's going on here? This number is the number that you multiply by itself 10 times to give you 7. I would call that, rather than the square root or the cube root, I would call it the, well, I just call it the 10th root. Okay? Because the numbers are going to keep going, 11th root, 12th root, whatever. Okay? That's what's going on, okay? That's a really big example. You don't really need to worry about that, but I'm just showing you, you can. These are the main important ones that we're going to see here. I wonder if that's the wind taking out a power station. Okay, so you've got the square root there and the cube root there, okay? So, let's bring this back to our list of laws, okay? Which again, it's not just, why are these true just because we said so? They're true because you can see that's how the rules of the game work. Okay, so I'm going to write in these two. A to the power of a half. When you see that, okay, what that really means is the square root of A. Okay, so if I gave you as an example 100 to the power of a half. 100 to the power of a half. That's the square root of 100, which is square root of 100. What's the number that you multiply by itself to give you 100? Multiply. It's 10. It's 10. Okay, and your calculator can do these two. It can do the square root. In exactly the same way, this is kind of like the same law but with another number. If you see a to the power of a third, it's not the square root, it's the cube root. Okay, so for instance, one of the cube numbers I know, if I gave you this example, 64 to the power of a third. Okay, now you might not know this number off the top of your head, and that's okay. But it's the cube root of 64. There's a number. If you multiply it by itself 3 times, you'll get 64. Does anyone know what it is?
12.
12
No.
times 12 times 12.
No.
That's going to be 144 times 12, which I think is going to be... Oh man, I shouldn't have done this. This is 1,140 plus 288. It's 1728. That's not 64. It's way too big. It must be something much smaller. Yeah. 4? 4. Let's try 4. 4 times 4 times 4. You do the first pair. What's 4 times 4? 16. 16 times 4. If you do those, that's 40. If you do those, it's 24. It's 64. It works. The cube root of 64 is 4. Okay? That's a less common number, but now you recognize it. Okay, so you can use that as an example. Okay.
Hold on, let me write that down.
All right, no problems. That's okay. Whenever you're unsure, okay, get your calculator out, and you will actually see. Let's see, where is it? Okay. You've got your square button, and right next to it is the square root. So they're beside each other. You've got a cube button, and just below that is the cube root button. So you can use that as well. Okay. So for instance, let's see. Let's do one more. This is going to be, well, let's try this. I think it's 125. Okay. Now, what's the cube root of 125? Dunno. Okay. So you get your calculator out. Okay. And on mine, it looks like it's right above the square root button. You go Shift square root, and you can even see that little cube root icon appears. Okay. Then you slap in your 125 and you hit equals, and what do you get?
5.
Say it again.
5.
5. 5 is exactly right. Now, by the way, you can test this out. If it's the cube root, that means if I multiply it by itself 3 times, if I multiply it by itself 3 times, I should go back to the original number, 125. 5 times 5 times 5. That's 25 times 5. Sure enough, that's 125, and you can check it out. Okay? So, in summary, you got these fractions in the index. You're going to get square roots or cube roots or 10th roots or some number like that. Okay? The most important ones that you'll see are when you got to the power of a half or to the power of a third.